Unless you have,
Yeah.
if you have specific problems ever. In other words, if you run into a homework problem or they covered something in class that you're not clear on, by all means, bring it up and we'll talk about it. But I was looking at your book and I didn't really expect you were going to have any problems at all on chapter 1. So given that, I think our best direction is just to continue with some of these problems. Just like we've been doing.
What we went over today, was it really helped having these past two lessons. Like all the other kids, they didn't know anything about vertical angles and linear angles and supplementary and complementary. They didn't know anything.
Well, the best thing we could possibly do is to keep you ahead of the game. Not just current, but ahead. And
like a lot of what we're working on now is using algebra.
Okay, but it's a difficult thing to do with any student to keep them ahead. Because for one thing, you need a really motivated student. Because most students, when they get caught up, they're ready to take a break. And then when they have problems, that's when they want help. But your best bet for being successful at math is
always
stay as far ahead of it as you can. So let's talk about problem number 6. Let me blow that up a little bit. I think we left off at 5. I reviewed our last lesson. That's one of the beauties.
Let me see 5.
One of the beauties of online is that you can go look and figure out where I left off with you.
Can I see 5?
What'd you come up with?
Can I see 5?
Oh, excuse me.
Okay, yeah, we went over that.
I thought we did. And then 6, I did not remember us going over.
Okay. So I'm going to start by using the linear angles and figuring out a lot of the unknown angles.
Okay.
So 140 plus 40 equals 180. So angle TRQ must be 40 degrees.
Correct.
And 110 plus 70 equals 180. So angle TQP must equal 70 degrees.
Okay.
And then using the rule that all 3 angles must measure to equal 180, all angles in a triangle must equal 180, I'm going to use those to find the final angle, so PTQ and PTR. So the angle of PTQ would have to be 60 degrees. Because 50 plus 7 equals 12, or 120, and 120 plus 60 equals 180.
Okay. Okay.
And 110 plus 40 equals 150. So angle QTR would have to equal 30 degrees.
Okay.
So
the analysis you went through was perfect, but it wasn't as quick. Notice they did something to this problem that threw you off, which is to put in this line TQ. Notice that if I leave that line off, I have, you can see my picture on the right here?
Mm-hmm.
Well, you immediately figured out that that angle was 40. What's that?
Oh, I get it now.
So what's angle T?
So T would have to equal 100. Okay, 90 degrees.
All right. In other words, there was a very direct way to get that angle, and that's the only angle they asked about. And what they kind of did was fool you by putting that angle in there and this degree. It made you just solve everything there was to solve. In other words, you solved that was 70, which made that 60. And of course, if that's 150, that's 30. And then you added 60 and 30 to get 90. But always remember that sometimes there's maybe a quicker way to get to the solution. And more importantly, when you go to take your ACT or SAT test, there's going to be lots of problems where they give you information that is not relevant. In other words, this line TQ and that angle 110 actually had nothing to do with the answer.
Okay.
And in fact, I'd have been better off had they not put it in there. Had they not put it in there, you would have gotten it much quicker.
It was just meant to slow me down.
Yes. Or meant
and I was not thinking.
Well, it's not that. You're just starting geometry. I'm not, you can't be expected to really know that they're going to try to fool you like that.
Well, they will.
Actually, you're right. They will. They do design these tests to try to fool people.
And see their problem solving. That's what IQ tests are about.
Yeah.
Taking the most logical way.
Well, if you find the faster way, then you're going to get it done quicker, and speed is always a fast factor. Mm-hmm. You may not run into speed as much of a factor until you take the SAT test.
Like, on the SAT, they don't expect you to show all the work you did.
No, they don't care about that at all.
Yeah.
But
they care about you solving the problem.
I mean, when you take your geometry test, you're going to be timed, right? You're only given a certain amount of time.
Mm-hmm.
But I suspect it's plenty. In other words, you're not going to find speed to be a problem. But when you take the SAT test, that is going to be really the first time you're going to be tested for speed.
Well, not exactly. I'm taking the Mensa test later this year.
Ah, okay. Okay. So you're well familiar with why speed is important.
Mm-hmm.
Okay.
Because if you can't get all the questions done, then you don't get any points.
Exactly. And I don't see speed as being a problem with you. You seem plenty fast on these. That's why I said that you probably aren't going to run into until the SAT because, I mean, obviously you're only going to have a certain amount of time to take your geometry tests in class. So speed is going to be a factor, but you're going to get done well ahead of time, I'm quite sure.
The thing I'm really worried about in the SAT is all these anagrams.
Don't worry about those. There aren't that many. That's not a major part of the test.
It's just...
You're talking the SAT?
No, I'm talking about the Mensa test.
Ah, okay. Mensa is a different story. I'm not really familiar with the Mensa test. So I can't tell you. But you're saying they have a lot of anagrams on there?
In the practice books that I've tried to use.
Okay.
They have a lot of anagrams that I can't solve.
Yeah, well, I'm sure that the Mensa test is going to test you in areas that you've probably never been tested before. Just because that's what they do. They're trying to test for IQ, not specifically geometry knowledge or algebra knowledge or anything like that.
They're not completely just teaching in math. They're teaching logic. They're testing for logic.
Exactly. Logic is what people really want to test. When you go to graduate school and you try to get into graduate school, they give you a test that's basically a logic test. It's an IQ test is what it is. They want the smartest people. And they don't get it necessarily from your math ability or your verbal ability, but they can come up with some logic questions that are pretty darn hard. Are you able to solve a Rubik's Cube?
No, I haven't ever tried.
I've tried and I can't do it. So there are definitely areas of logic that I'm good at and not good at. And three-dimensional geometry, like a Rubik's Cube requires you to use, is tough for me. Well, some
But
people it's not tough for. It's just, it depends on
I,
who you are.
well, the Rubik's Cube I've always had was like you couldn't exactly turn all the blocks. They were just kind of stuck and
Hmm.
they were very stiff.
Oh, well, that's got to make it doubly difficult. But no, I never did bother to learn the algorithm that you need to use to solve the Rubik's Cube. And there is an algorithm. It's like you take one color and always leave it in the same position and work around that color. That's the way you're supposed to solve it. But left to my own accord, just you give me a Rubik's Cube and left to my own, I'd never get it. I mean, it would take me a year. But so I'm not particularly good at those kind of puzzles. But
Hey, you could
that's
get
the kind
better.
of stuff that your Mensa test is probably going to test on, is things like that.
You could get better.
Yeah, yeah, although IQ is one of those areas that it's hard to get better. General thinking on IQ is whatever your IQ is now, it's going to be that in 5 years from now. It doesn't matter what you do.
Well, if you learn new tips for the Rubik's Cube.
Well, yes, and there's ways, if you had lots of practice at doing logic puzzles and games, that would help you on any IQ test. But a lot of IQ tests test things that they're really testing your basic IQ. And your basic IQ is not something that's easy to change. No matter how much you work on it or study, it's hard to increase your IQ or decrease it. So that's why they're looking for people. Everybody's always looking for high IQ people because they know that, wow, if somebody has a high IQ, they got potential and they can always learn just about anything.
They're going to think more logically and rationally.
Exactly. Whereas if you have a low IQ, then no matter how hard you work, it might be tough for you to figure out certain things.
But if you have a normal IQ, but you have a good work ethic
Not
and the
necessarily.
desire to get it
Incidentally, a
done.
normal IQ is 100. And
Yeah.
if you go through the population, you'll find that 100 is not very smart in adults.
My dad has an IQ of 145, I
I was
think.
going to say, most all the adults you probably know have above average IQs. Certainly your teachers, your parents. Um, yeah, 100 IQ is actually a pretty average person. Uh, you would probably say they weren't that smart, but um, so it'll be interesting. I'm curious to know how you do on your Mensa test. Let me know. Um,
Okay, but I don't know. I'm probably gonna take it in like a couple months though.
okay, okay. And I know that there's a certain level you have to get to join Mensa, correct?
Yeah. You
But
have to get 130.
okay, but they probably still give you your results even if you don't get 130, don't they? Like if you got
Oh
100,
yeah, yeah, they will.
they'd let you know. Yeah, no, I'm very curious to see what you get. So keep me posted. Okay, let's have a look at this problem. Here's what they tell us, is that x is equal to 2z and y is equal to 3z. Can we solve for z?
Okay. So if that means 180 is 5z, that would mean 180 divided by 5
Well, hold on.
would be
Okay, I see where you're going. In other words, you're substituting for the x and the y. For x, you're
Is
going
that
to for x, you're going to write 2z, and for y, you're going to write 3z. And now you know that those add to 180, so you get 5z equals 180.
so? Then I would divide by 5, and I would get I'm drawing a blank right now for some reason.
I've written the answer on there.
Oh, 36.
Uh-huh.
Okay. So 36
Let me ask you
equals,
something. Would you typically do that manually, or would you do this with a calculator?
manually.
Okay. Okay. Most of my students, I tell them, have a calculator in front of you when we do our sessions. But in your case, I'm going to say don't have a calculator in front of you when we do our sessions. I would rather see you do these manually.
Mm-hmm.
Just because I think that's a good ability to have. At some point in your life, you're going to end up taking tests that don't let you use a calculator.
Uh-huh.
And so you're going to have good arithmetic skills. And this was not that hard, dividing 180 by 5.
Yeah, it's just,
All right.
I don't know.
Notice again that this z didn't even enter into the picture, did it?
No.
No. We worked entirely with those two linear angles. Okay, number 8. What is x in terms of y?
Okay.
Start with the equation. Write an equation that describes that picture.
So 150.
No, I want you to write it as 30 plus x plus y. That's what I
Okay.
want you to say. In other words, I want you to
30,
do one step at a time, and you'll see why. What's that equal?
30 plus x plus y equals 180.
Okay. Now, they want you to solve for x in terms of y. So solve this equation for x. What do you get?
Okay. So,
You want to move?
do they give me enough values?
Yeah. Notice that all 5 answers have y in them. So I see why you asked that question. No, they do not give you enough values to solve for x, but they do give you enough to solve for x in terms of y. In other words, if I move the y over to there and I move the 30 over to there, what do I get? I get 150 minus y, right?
That's what my initial guess was.
And that's the answer. Notice that all 5 answers have a y in them. And you're right, because there's only one equation and there's 2 variables, there is an infinite number of solutions for x and y. The only thing we know is that x and y have to add to 150. But that's all we know. As far as what each one of them is, it could be anything.
Yes.
All right.
It can't be determined.
Right. And they didn't ask you to determine it. They just asked you to give it in terms of the other one.
Okay.
All right. Hold on a minute here.
Okay.
Just a second. It takes me a while. Under Windows 10, so much harder. to do this tutoring. So,
In triangle ABC above, x equals blank. So we have, okay. So we have three angled measures, x, 3x, and x over 2.
okay, so always do geometry with the intent of writing an equation that you can solve. Okay, so what equation can you write?
So 4x
Let's
plus
take it one
x.
at a time. In other words, you're always doing multiple steps in your head, which is fine, but
3x plus x plus x over 2
equals,
180.
okay. Now,
Okay.
what's the next best step?
Multiply all values by 2 to get rid of that x over 2.
Very good. So what comes next?
6x plus 2x plus x equals 360.
Now?
You add all these x's up to get 9x. 9x, so 360 divided by 9 equals 40. So the answer is 40.
Yes. And that's the way you want to do all geometry problems, is you want to start out thinking, what equation can I write? There's a variable in there, so I know I'm going to end up with an equation. And
That was surprisingly easy.
it was. And I like that second step, getting rid of that denominator, because there is a choice. In other words, I could have just added them together, and I would have had 4.5x equals 180. But that's a harder problem because there's still a fraction in there. Now it's 9/2 x equals 180. And now 9x equals 360. So you get to the same answer. But I love getting rid of denominators as quickly as possible, which is what you did.
Okay. In triangle ABC above, x equals. So our equation, 30 plus x plus 20 equals 180.
Next line.
Wouldn't x plus 20 be in parentheses? Or, no.
No, you're right. It is in parentheses, but I left them out because they're not needed. In other words, I could have put them in, but because that's a plus sign, they are not needed. If that was a minus sign, they would be needed.
I'm going to do maybe 2 steps. So I'm going to subtract the 30 and the 20 from 180 to get 130.
Well, what's the simplest way? What's the next step? If you weren't talking geometry and you were talking algebra, how would you solve this equation?
Add similar terms.
Okay, so you get 2x
plus 50.
All right.
So subtract 50 from 180 and get 130, and then divide 130 by 2 and get 65.
There's your answer. It's always about setting up an equation and solving the equation.
In the most logical way.
Well, hopefully the quickest way, the shortest way. Some methods have 8 steps, some methods have 6 steps. You want to do the one that has 6 if you see it.
The angles of a triangle are in the ratio of 2, 3, 4. What is the degree measure of the largest ratio? So.
Of the largest angle.
Okay.
So here's a triangle. What are we going to...
Maybe we'll call 2x.
Very good. The secret to this problem is to introduce a variable.
We'll call 2x. We'll call 3, 3x and 4x.
Now, those three angles are in the ratio of 2 to 3 to 4.
So
but
9x
they never
equals...
introduced the x. You had to come up with that yourself.
Yes. So then you add up all the x's and get the equation 9x equals 180. You divide by 9 and get 20. So you multiply 4 times 20 and get 80 degrees. So 80 is the largest angle.
Good. Good. It's not that easy to see the problems where you have to introduce a variable that wasn't given to you in the first place.
It seemed easy. And I was actually making a blind guess.
Well, that was a good guess. About 12.
Okay. In the figure above, x plus y equals, okay. So we'll use the linear angles property to figure out that missing angle would equal, 40 degrees. And we don't need to find out those other two angles. Wait.
So there's 40.
Okay.
So that's what we know so far.
So we don't exactly need to find those other two angles. We just need to use math to figure them out. So, no matter what those other two angles were, the, x and y would still add up to be the same, right?
Yes.
So, therefore, we can imagine that those other two angles equal 180. No, that all those angles add up to equal 180. So,
very good.
We'll just presume.
In other words, I could make that 100 and make that 40, and it wouldn't matter to my answer, right?
Yes. So x plus y equals 100. No, x plus y 80, and so x plus y equals 220.
Right. That was actually very brilliant. I didn't come up with that myself even. I was sitting here trying to figure out what it was going to be when you came up with that statement. Let's see what I would have done here. And I love your logic. You knew that this line could be drawn any old way and it would change these angles, and so those angles aren't critical to our answer.
It would just equal the same thing. It would have to.
Yeah, although the way you solved it kind of was a little strange. Here's the way I would have solved it. This angle has to equal 180 minus y.
Yeah.
Angle has
and the other
to equal 180 minus x. And now I can say 40 plus 180 minus y plus 180 minus x equals
180.
Right. Now if I remove all my parentheses, I get 400 minus y minus x equals 180.
It looks like you did y minus y. Okay, there.
It came out like that. Okay. Now, what we're trying to solve for is not y or x, but y plus x. Well, if I take that negative y minus x and move it to the other side of the equation, it's going to come out y plus x, right?
So 180 plus y plus x equals 400. And then what you can do is subtract 180.
Exactly.
And get 220.
So I get when I solve it purely algebraically, I get the right answer. Whereas the way you solved it was a particularly ingenious way in that you knew it didn't matter what each of those was, so you could make up numbers. In other words,
But they,
let that
but
equal
the,
100 and let that equal 40, or you could have let that equal 90 and that 50, and then you can solve for it almost more directly.
well, it did matter. It did actually matter what the those angles were, because if they were 200 and 200, that wouldn't have worked.
True.
But if they added up to 180, then.
But what really was important was what their sum was.
Mm-hmm.
In other words, their sum is 220 always,
Mm-hmm.
which means that these two angles merely have to add up to 140 in any combination you want.
I think I might use your method.
Well, my method's probably a little more rigorous. My method's a little purer because it's all algebra. I didn't
Mm-hmm.
have to go in and pick numbers.
Yours was also pretty ingenious, too.
Yeah, well, sometimes I couldn't tell when I was labeling these whether it was going to come out to something I'd be able to solve for y plus x. But it did. It just came out a little strange. In other words, the second step I had a minus y minus x. But that's good. I mean, had it been minus y plus x, I couldn't have solved it. But as long as I can move it to the other side and turn it into a y plus x, I'm good to go. So, all right. Let's see. That is page 151. That was basic. This is intermediate.
Okay. If AD, what do those little lines mean?
It means parallel to. In other words, if AD
Okay.
is parallel to BC.
Even though it doesn't look like it.
Well, you're right. It doesn't. They did not draw it to
But,
be parallel. But they're
but you
telling
cannot,
you it is parallel.
yes. But you cannot judge geometry by look.
Exactly.
It has to be math.
Right. It has
And
to be whatever they're saying, it has to be, is what it needs to be. Let me see if I can figure out how to draw this. I will draw it parallel as close as I can.
okay, so I'm going to be using a lot of properties here, and I might be doing the tedious way. If I'm wrong, correct me, but this is the way I'm thinking. So 70 plus 60 equals 130. That must mean angle DFC would equal 50 degrees. And using the vertical angle property, that would mean BFG would also be 50, meaning angle FBG would be 70 degrees. So those triangles are congruent. Then using the linear angle property,
Now, hold on 1 second. They're actually not congruent. They have the same angles, so they're similar. But
okay.
we don't know any sides. Remember, there's a difference between congruency and similarity. Congruency, they have to be identical. 3 same sides, 3 same angles. But that's not the important property. Remember that this line, and here's what that means, that line is parallel to that line. That says something about this angle and that angle. What does it say about that?
It means that x is 70.
Yes. In other words, it all comes down to 2 parallel lines and a transversal.
Okay.
1, 2, 3, 4, 5, 6, 7, 8. 1 is equal to what?
1 is equal to 4. 3 is equal to 2. No, 1 is equal to 4, 5, and 8.
Okay.
2 is equal to 3, 6, and 7.
Okay. That's all you need. And that's enough information to answer most any kind of question like this. Okay? And in fact, if they told you that this angle was 70 and that x was 70, that's enough information to know that line AD is parallel to line BC. In other words, it's impossible for those angles to be equal and for those lines not to be parallel. That parallel thing works in both directions. If I tell you that angle 1 is equal to this angle down here too, then that says that's parallel to that. It's a theorem and its corollary.
Okay. So, in triangle ABC above, which of the following must be true? So let's start by writing an equation. Okay, so 3x minus 15 equals 180. Is that correct?
Correct.
So 3x equals 195 divided by 3, x equals, x equals 63.
Okay. So now let's examine each of their three, and furthermore...
Wait. So 3 times 63 equals 189, not 195.
Right, but it's 3x minus 15 that's equal to 180.
Oh, okay.
In other words, each of these angles is not 63. This one's 63, that one's 63. This is 63 minus 15. So this is 48.
Okay.
Okay. In fact, let's label it 63, 63, 48. Now, here's a principle about geometry that we haven't talked about yet. They gave us a side length of 10. Do you know any other side lengths? They gave you CB is 10. Can you figure out any other side lengths?
Okay. That must mean AB is also 10.
Yes. And it means that AC is less than 10.
Less than 10.
Has to be the smallest side.
It is an isosceles, so that means only 2 is correct.
Well, 1 is correct. X is greater than 50. We figured out that it was 63.
Mm-hmm. Oh, yeah, no, sorry.
AC is less than 10 has to be correct.
Mm-hmm. And 80 is greater than 10 is not correct.
Greater than 10, it's equal to 10.
Mm-hmm.
So 3 is not correct, and the only two that are
1 and 2 only.
1 and 2. Personally, I think this geometry is much more helpful to you than what you're learning right now. I hate to say it, but...
In class?
Yeah.
Right now, we're learning how to bisect angles.
I know. I've gone over this chapter 1, and I just think they spend too much time on, I don't know. I have my disagreements with the curriculum of most of the math courses taught. I don't like the way they teach them. I'd rather see most important stuff first, which is what you and I have covered in geometry. In other words, starting with lines and angles and then triangles, and then we're going to do circles, and then we're going to do quadrilaterals. Then go on to proofs, reasoning, and stuff like that. But they're going to teach it the way they're going to teach it, not the way I think they should teach it. So let's look at 15. Here we have a right triangle whose area we know. Area equals 6. BC is 1/3 the length of AB.
So I've already figured out the lengths of AB and BC.
Okay.
BC is one unit, and AB is 3 units.
It's the area of that triangle you just gave me.
Now, I think I'm forgetting that theorem you taught me, that formula.
Let's always start with the general formula. The area of a triangle is 1/2 the base times the height.
Yes.
Okay.
So,
and let's
so
back here and do what you did on that one problem. Let's put x's in there. In other words, when it says that BC is 1/3 the length of AB, then I can introduce a variable, and I can say it's 1x, and that's 3x. Now, area equals 1/2 times x times 3x. Well, that's equal to 3/2 x squared. And they're telling me it's equal to 6.
Okay.
So solve that bottom equation for x.
So what I'm going to try and do first, I think, is get rid of that denominator.
Okay. Yeah, you can multiply both sides by, let me give you another tip here. When you have a fraction like this, you can get rid of both the numerator and the denominator by multiplying both sides by the reciprocal. In other words, if I multiply both sides by 2/3, notice that in one step, both of those go away, and I get x squared is equal to 4. So what's x equal to?
X equals 1.
If x squared is equal to 4.
Oh, x equals 2.
Right. So that makes this side 2, and it makes this side 6. And now let's check, always check, is the area of that triangle equal to 6? It's 1/2 base times height.
Okay. So 2 times 6 equals 12, and 1/2 of that is 6.
So that model is correct. In other words, that gives you an area of 12, or excuse me, it gives you an area of 6, and this side is 3 times that side. So another good place where you kind of have to enter a variable if you want to do it cleanly. Now, when I say cleanly, I'm sure that you could have chosen a ton of numbers, and by trial and error, you would have gotten the right answer before too long, right?
Mm-hmm.
In other words, if you didn't know to introduce a variable, maybe you would have started out with 1 and 3, and you realize, well, the area of that is only 1/2. So let's try 2 and 6. The area of that is 6. Boom, we got our answer. But that's not a great way to solve these math problems. It works when they're easy like this, but the much better way is to introduce that variable and then solve it algebraically.
So now that we have our lengths, we can use the Pythagorean Theorem. A squared plus b squared equals c squared. So 6 squared plus 2 squared equals 40. And so 40 is also, yes, I got to that. 40 is also the square root of 4 times the square root of 10.
Right.
And the square root of 4 is 2. So 2 times the square root of 10.
Right. Now, in reality, they didn't ask for the hypotenuse. The only thing, oh, excuse me, they sure did.
Yes.
I was thinking they were merely asking for what BC and AB was. I didn't read the whole problem. Yeah, you're right. You did need to solve for the hypotenuse. And it's this one right here. Yeah, very good.
Okay. What is the length of the hypotenuse of an isosceles triangle of an area 32?
Okay, first of all, let's talk about what an isosceles right triangle is.
Okay, yes. So that means, I get that. So that means the two angles coming off from the vertex that is 90 degrees, then they must be the same.
Correct. So the height is the same as the base.
So, and
they're telling us the area.
So what times what equals 32?
Well, let's start with the general formula. Always. Area equals 1/2 base times height. They've told us the area is 32. What am I going to put for B and H?
Okay. For B and H, 8 and 8.
How about X and X?
Oh, sorry.
In other words, I want to do it rigorously, algebraically rigorous. I don't want to have to make up numbers. 1 second. Hello? Yes, it is. Yes. I'm definitely a tutor. Unfortunately, I'm in a session right now. Can I call you back when I have it'll be a little more than an hour, like an hour and 10 minutes. I do. I will just call back this number. Thank you very much. Bye bye. Sorry about that, Bolton.
It's fine.
Okay, so now what? I got 32 equals 1/2 x times x. Can you solve for x?
So 1/2 times x squared, which, okay.
Okay. So I got 32 equals 1/2 x squared.
So,
Get rid of that.
Then we, okay. Yes, then we multiply both sides by 2, and x squared equals 64.
Making x equal
to 8.
So I know this side is 8, and I know that side is 8. Now what's the hypotenuse?
So 8 squared plus 8 squared equals the hypotenuse. So 64 plus 64 equals 128, right?
Correct.
So what is the square root of 128?
Okay. Think of factors.
Mm-hmm.
And you think of factors of 128 where one of them is a perfect square number.
Oh, I get it. 16, I think.
There's a bigger one. And if you can find the biggest one, it shortens the length of the problem. What's half of 128?
Half 64, so 2 times 64.
Okay.
Or, yeah.
There's your answer right there.
Yes.
8 root 2. Now, before we go on, that was the hard way to come up with that. Once we came up with 8 and 8, then applying the Pythagorean theorem was fine, but it wasn't necessary. And here's why. If, and I don't think I've talked to you much about these, but there's two very special triangles that you're going to get a lot of in the next few.
Oh, yep. You've talked to me about these.
I thought I had. Yeah.
45, 45, 45, and then the 60 and the 30, right?
Yeah. Well, this we know to be 45, 45, right?
Mm-hmm.
So if we know the dimensions of the unit one, this has got to be similar. What's the similarity ratio?
The similarity ratio is times 8.
8 to 1.
Yes.
Which makes the hypotenuse 8 2.
Times the square root of 2.
Immediately.
Okay. That makes...
In other words, whenever you have one of these triangles, it's either a 45-45 or a 30-60, it's going to be easier to solve for a side by using your knowledge of those two unit triangles. And let me just draw the other one, 30-60. Remember the dimensions on this? That one's 1. Square root
1/2.
Square root 2. In other words, here's your two triangles. Let me erase everything else. You can go a long ways in geometry just knowing these two things right here that you see. Because whenever you come up against a 30-60 right triangle or a 45-45 right triangle, you can solve it almost instantly. Whereas if I give you and say solve it using the Pythagorean theorem, there's a lot of math in that. It's quicker if you know this. Plus, sometimes they won't always give you everything. In other words, maybe they'll give you, this is a 30-60, and they'll tell you this side here is 3 root 3. What are the other two sides? Notice that if you didn't know these unit triangles, you'd have no way to solve that.
Yes. So the other sides would be 3 and 6. The hypotenuse would be 6.
Right. In other words, the similarity ratio is 3. Always.
I'm writing these down.
Always get in
Don't erase. I'm writing these down, so please don't erase them.
Okay. No, I wouldn't want to, because if there's anything I want anybody to memorize taking math, it's these two triangles at the top. Those are called special triangles. They'll even have a special chapter on them in the book, all about those two triangles. And the reason they're so important is because it turns out that when you take geometric shapes and stuff and start chopping them up, you end up with a lot of 30-60 triangles. In other words, if I take an equilateral triangle, which means 60-60-60, and I drop a vertical, makes this 30-60. And it makes it a 30-60 right triangle. So you're going to see lots of problems that have these kind of figures in them, where they've chopped up triangles or shapes, and you end up with a 30-60-90 or a 45-45-90. And that's where you need to know your two unit triangles. Or trigonometry. That's the only other way to figure them out is, and since you take geometry before you take trig, you're going to need to learn those two triangles.
Yeah, I'm going into Algebra 2 honors next year, and trig honors, and then math analysis honors in junior year.
Good, good. And then you'll take calculus as a senior, I'm sure.
When I was signing up for honors, though, my friend told me that the only thing honors do is it looks good on your record.
Well, for
and
sure
he's
that. But am I wrong that it doesn't improve your GPA? I mean, if you
no,
get,
it does.
yeah, it
He's
improves your
oblivious to that.
GPA also. Yeah.
He's oblivious that it raises your GPA by 1 full point.
Yeah, that's what I thought. Yeah. Yeah. So,
Yeah.
and a B in honors would be the same as an A in non-honors.
Yes.
Correct. All right. Bolton, I'm going to let you go because I'm sure your brother is anxiously awaiting my phone call.
Okay.
All right. Talk to you later.
Yeah. Bye.